Hello guys, hello everybody. I have no microphone. I have no microphone. Okay, my gosh. So I'm gonna be able to derive the how to have a formula known as the Reynolds number. So it is the Reynolds number is unitless or have unit. So how can we do that? Okay, I discussed a lot regarding momentum transfer, right? I think that was how many months had passed. Now this is focus now for the mass transfer, right? So I could not remember what is the formula for that, but if we will try to recall the units, then we can really recall for that. Okay, so so do you believe that that this Reynolds number came from the law of Newton. That's why we have what we call as non-Newtonian fluid, because in the topic of momentum transfer is more on the application of the Newton's law of viscosity. Okay, so it's gonna be in there that we apply the no, not all laws of motion. Actually, there are three laws of motion in physics, right? The Isaac Newton, but it's gonna be, I think it's gonna be the first and the second laws only, the law of inertia and the law of acceleration. It could be applied, but the third law, which is the law of reaction, right? You remember that one? That in every reaction, you must always have an equal and opposite reaction. The third law, it's gonna be like that. Only the first, I think, and the second. Okay, so as we can remember also that in the mass transfer, we need to use the fixed law of diffusion, right? The steady state diffusion. Okay, and I discussed it also last week, something like that. And then last 2 days ago, I discussed about heat transfer. We used also the Fourier's law of conduction and the Stefan Boltzmann law of radiation. Okay, the three types of heat transfer. But we go back to the Reynolds number. I love really to recall what comes in my mind like this, and then I be able to share to you guys. Okay, for example, if you this is very important because in there that we can determine if the flow of the fluid is laminar and turbulent. Okay, and it's very important in calculation of the volumetric flow rate and the mass flow rate of liquid or fluids or even gases that will pass through a certain medium, something like that. Okay, so as we can remember, it could be an orifice meter, venturimeter, a nozzle, a diffuser, something like that, or a pipeline, a vessel, a tank. What else? A lot. Okay, so it's gonna be like that. Okay, so I'll be showing to you guys. So Newton's law of viscosity, of course, obviously there must be viscosity there, right? Newton's law of viscosity, or else why it's carrying the term viscosity. Okay, viscosity is a resistance of the fluid to flow. Okay, it is the resistance of the fluid flow. If that, for example, if the flow is here and the counteract will be the resistance, just like the electricity, the resistance. Okay, so V voltage equals to current times resistance, and the resistance will counteract the voltage, something like that. Okay, you get the point, or something like that. It's just the same resistance to the shock. Okay, and in fact, resistance is a negative force. Okay, like that. It's always counteracting the applied force. Okay, that's the principle behind resistance, guys. Okay, actually, there's a lot. If you study, I don't think so with Bachelor of Science in Chemistry, BS Chemistry. Okay, like that. Because before, when I was in college, also I attempt to take that course. Okay, but I changed my mind to BS Chemical Engineering because it's very far. University of San Carlos Talamban, something like that. And I remember also the scholarship did not have that kind of course also, limited to engineering like that, okay? Types of engineering, that's why I choose this course, BS Chemical Engineering. If there is BS Chemistry, I will go to BS Chemistry because I like chemistry too much. Really, but there's nothing. The scholarship is only engineering, types of engineering. Okay? It's gonna be like that. So, basta dito ang mass comm. Okay? Because mass communication is my favorite, okay, course. Because I want to become a broadcast journalist. Okay? When I was young. Oh my gosh. Okay? So, go back to the Reynolds number, right? So we represent RE is our Reynolds number. Okay, we designate this symbol, or shall we say, a code or nomenclature. RE, Reynolds number. So this is very, very familiar in fluid flow, fluid dynamics, okay, fluid mechanics. Could it be a static or rotating, something like that? So this is applied. This will be applied. Okay, Reynolds number. So based on my brain cells. Okay, because maybe I can forget, right? So it is the density raw times the velocity times the length, okay, over the viscosity. Oh my gosh. And you should be careful also, there's two types of viscosity, the kinematic viscosity, okay, and the absolute and dynamic viscosity also. You should be careful also. But since we cannot really distinguish, then we will rely to the units. Okay, rely to the units na lang siya. Okay? So, we apply the second law of motion, which is the law of acceleration of Isaac Newton. Okay, what's that second law all about? By the way, let's make it clear. We are here to derive the Reynolds number formula. Reynolds number is not unitless, guys, ha? So it's not the same with other, because others are unitless also. Okay? You get the point? Something like that, okay? So before that, I'm gonna introduce to you the formula of resistance also. But this is very common in the transport phenomena. Okay, so we have momentum transfer, and mass transfer, so the K there is just the same, but it will be just substituted to other terms. For example, if you refer to the mass transfer, so let's say the resistance of the mass transfer, minimum resistance is equal to the length over the diffusivity. And this diffusivity is the mass diffusivity. Ganon. So, gidinot good siya nga DAB. Okay, wag siya. Okay, resistance is equal to the length over diffusivity or mass diffusivity. Now, length can be also interpreted as the thickness, something like that. But anyhow, you can understand the problem. Okay, when you draw, when you illustrate, something like that. Okay, you can understand. Oh my gosh, the length is just only the thickness, something like that. Okay, you'll understand later. Okay, because sometimes gonna be like that, sometimes gonna be x, because x is usually the the horizontal distance covered fluid to move from one point to another, something like that. Okay, so we have also the r, that's it in terms of mass transfer, and also the resistance in terms of the heat transfer. So more guys, the numerator is the length also, the thickness, but this is now over to the thermal conductivity. Okay, what do you mean with thermal conductivity? The property, this is a physical property of a substance that will conduct electricity. Okay, that's why it's very obvious. Conductivity. Okay, since that is thermal, so it is driven in the change of temperature. Okay, temperature gradient, our driving force. Since temperature really is the term we refer to how hot or cold a substance or object really is. So that means that it's gonna be the heat energy. Okay, when we mean of heat energy, so it can be distinguished through the change in temperature, and the temperature gradient is our driving force in here. Okay, it's not the heat. Okay, it's the temperature. Okay, you got a point? Something like that. Okay, of course, it's already hit, then your driving force also hit, so there's a redundancies for that. You cannot say that, okay? So resistance is equal to length over the thermal conductivity. So the small k, oh my gosh. Muna siya in heat transfer. Okay, guys? Muna siya ang hitabo. Okay? Then we can also say that the resistance also of in the flow will be equal to length also, but this is now the heat transfer diffusivity. Momentum transfer coefficient. Okay? Momentum coefficient na siya. Dili na siya diffusion coefficient, thermal conductivity, momentum diffusion coefficient, or momentum diffusivity. Right? It's very clear, ha? Now we will derive na. Okay. The second law of Newton is the law of acceleration. Okay. Force is equals to mass times the acceleration due to gravity. Right? F is equals to mass times the acceleration A. Ganun siya. Okay, so in this formula, you can play a lot of equations for this. We try to correlate to the formula of force in terms of pressure. Okay, right? Mass in terms of molar mass and in terms of density. Right? So you can play around so that you can create your own formula, something like that. Okay? And then letter A is an acceleration. Acceleration is the rate of change of velocity, right? The definition of acceleration in physics. Because the rate of change of speed is also acceleration, right? Because velocity and speed is just the same, only matters the direction and the magnitude. Okay, so again, review. Scalar quantity is the speed, vector quantity is the velocity. And then the velocity refers to the displacement, and the speed refers to the distance only. Okay, so it's gonna be like that velocity is equals to the speed over time. Okay, you get the point? Ganun siya. Speed over time. Acceleration, speed over time. Ganun siya. Okay, meter per second squared siya. So, ano yung acceleration? The rate of change of velocity. Okay, speed naman siya daan. So, speed over time. Okay, rate man siya. The rate of change of velocity. Or rate, may times the denominator, right? Always remember that one if you talk about the rate. Okay, and then we have also the acceleration in terms of speed, right? Okay, you get the point? So, this is gonna be speed over time also. Okay, it depends on the situation, ha? Okay, so, muna siya natabo. So, okay. Now, mass. So, mass. Because we're in momentum transfer, guys, we're dealing on the flow. F-O-L-O-W. Meaning there's a motion or the movement of the fluid from one point to another. So, automatically, we can really assess and evaluate that it talks about how light the liquid and how heavier the liquid. So it talks about the density, right? Normally, if I see water in front of me, oh my gosh, it is light or heavy or something like that. So it's gonna be like that always, okay? If water, okay? So how viscous the water really is, or how viscous the oil really is, something like that. So we're talking about the motion. Okay, now, so talking about the density, so we connect that to the very, very, very basic equation of density that we learn in elementary education. In grade 6 or grade 5 elementary level, we know already that density is equals to mass over volume. Okay, so density is equals to mass over volume, then automatically we can say that mass is equals to density times the volume. Okay, so density times the volume, ano siya? Okay. And the acceleration, since we know that is meter per second squared, right? So the standard acceleration due to gravity is 9.81 meter per second squared, or 32.2 feet per second squared. Something like this is the value, right? Standard value. Now we can say that a meter. So meter is the unit of length, right? Okay, I will put length. So in the numerator, because that's a meter. Okay. And then over second squared. What is second? Second is a metric system unit of time. So it's gonna be like T also raised to the power 2. Capital T raised to the power 2. But take note, this capital T is not the temperature here. It's the time. Okay, because it's acceleration. Okay, so T raised to the power 2. Ganon. This is going to be the equation already. Now, to simplify further, you need to put units. Okay, so that you can cancels out, you can simplify. That's the technique of derivation. You'll put always units so that you can really cancel what's gonna be left. Oh my gosh, it's gonna be like that. Okay, so you should be clever enough to troubleshoot the units. We should master that if we're taking engineering course. We need to master that. The cancellation of units, simplification of units, because in that, even though we will not memorize the formula, we can identify that is the formula. Okay, if you have only the units. Get the point? For example, a density, kilogram per cubic meter. Oh my gosh, there's mass in the numerator and there's a volume in the denominator. So automatically, mass over the volume. So even though you forgot that formula. So that's the technique. Okay, if you memorize and you fail to recall it once again, then you can remember through its units. You get the point? Something like that. Okay, going back. So density is equals to volume times length over capital T raised to the power 2. Ganun siya. Now, let's break down the units. Density, we will just use kilogram per cubic meter. Not the other one, the 62.43 pounds per cubic feet. No, it's not that because English unit. We will be dealing with metric system. Okay, like that. So density is gonna be kilogram per cubic meter. So at 4 degrees Celsius, the density of water is 1,000 kilogram per cubic meter, or it will be equal to 62.43 pounds per cubic feet, or it will be equal to 1 grams per ml, or 1 grams per cubic centimeter. Okay, because cubic centimeter is just equal to milliliter. 1,000 milliliters is just equal to 1,000 cubic centimeter. Okay, so it's very easy to convert in terms of meter because of that conversion factor. Okay, so density is equals to kilogram per cubic meter. Okay, guys, and then the volume will be, of course, the unit of volume. Actually, the unit of volume, there are a lot. It could be gallons, liters, but you will try to agree with the units of the cubic meter. So you will use also cubic meter. Okay, like that. So this is assumed to be a cube. Okay, cube, C-U-B-E, diba? The volume of a cube is equal to length times width times the thickness, right? It's gonna be like that. For example, the cube of an iron, length times width and thickness. So that's why if in terms of meter, let's assume a basis of calculation of 1 meter per side. Something like that's going to be 1 meter times 1 meter times 1 meter, and the thickness also is 1 meter. That's why it is cubic meter. Meter times meter times meter is equals to cubic meter. Okay, 3 times by itself. Okay, so muna na cubic meter na siya. Hindi na siya magic. It's really in the formula. Length times width times the thickness for the cube or for the volume. Okay, now it's gonna be like this. So liter over t squared. O ganon. Hala. Okay. Now, investigate, guys. Investigation din mo siya po. Oh my gosh, ganda na, no, diba? So if we try to put seconds in time, because seconds is the unit of time, right? So you will substitute, right? Okay, substitute seconds na ka sa time. Ako naman na siyang gi-illustrate, ako na siyang gi-emphasize na it's gonna be length over t squared, the general. But the specific is seconds talaga siya. And then you will be able to do this. So kilogram, cubic meter. Now, what is capital L? Is this length. So to agree, this is also meter. So times meter. Okay. Then t raised to the power 2. This is also second raised to the power 2. It's gonna be second raised to the power 2. So it's gonna be like this. Second raised to the power 2. Okay, guys. Ano na siya natabo? Okay. Okay, guys. Ano na siya ha? So, kilogram per cubic meter times meter per second squared. And let's simplify this one. Okay? Like that. If we simplify this further, the unit will be Newton. Okay? Kilogram meter per second squared. So that is the unit of Newton. The basic unit of force is Newton. Okay? Kilogram meter per second squared after the cancellation of this matter to the cube, but we are not interested for that because we need to derive the formula of Reynolds number. Okay, it's gonna be like that, ha? Now, so muna siya nahitabo. So density, okay, density. Okay, density muna siya. So density, okay, ganon. Now, let's investigate here. Cubic meter times S2 is gonna be m raised to the power 4. Multiply lang yun siya. Okay? So, i-add mo yung exponent, add the exponent when you multiply. Right? It's gonna be m4. Okay? So, it's gonna be m4 over S squared. So, m4 over S squared. Now, guys, find a very common quantity, a physical quantity that would describe this m to the 4 to the S2. Okay? And it is very familiar in momentum transfer or any, science topic or any major in chemical engineering or in this chemistry. Okay? But, so you cannot use acceleration already. Acceleration is not popular to be used in the steady state flow, especially in convective mass transfer, convective heat transfer, and convective momentum transfer. It will not be applied. The always basis for that is the velocity. Bear that in your mind, that in a momentum transfer, guys, the velocity is our driving force. Okay? So the velocity is our driving force. The driving force of heat transfer is the temperature, and the driving force for mass transfer is the concentration. So you need to troubleshoot the driving force and the gradient and the difference. Okay? Muna siya yung metabo. So kung velocity ang gradient, we are after only for the velocity, not for the acceleration. Or else we will not do this for the purpose of derivation. Okay, so m to the 4th S2. So if we try to, simplify that one, we can still obtain velocity. So the formula of velocity is meter per second, right? So let's break this. So the density is equals to velocity. Okay, guys. Since you get the velocity already, what will be left is meter squared and second na lang siya. Get the point? Because that is M4. Gikuhaan mo sa ka M. So, ang mahabilin, M3. Okay? Gikuhaan mo sa ka S. Ang mahabilin is only S. So, velocity. So, M3. So, M3, since M is matter, we will use L raised to the power 3. Because it's just the same. M is matter, the unit of length. So, that is m to the power of 3, or it could be length raised to the power of 3 for general purpose during derivation. In derivation, sometimes we use the general okay, so that we can come up with the formula. Okay, because the formula is basing man siya sa mga different units. Okay, for example, density, there's a lot of units of the density. It could be pounds per cubic feet. It could be kilogram per cubic meter, something like that. Okay, it could be grams per ml. Okay, it could be kilogram per liter. Okay, so at least you can memorize at least one and you can convert over the other. But to make it easy and fast for you, especially if you face certain examinations in the future, you have to memorize na lang gid siya, especially the kilogram per cubic meter, the pounds per cubic feet, and the grams per ml. Okay, tulo lang siya ang i-memorized. Okay, because it will take time to convert naman talaga siya. And it will take time also to scan the handbook or the book. So memorize na lang siya. 1,000 kilogram per cubic meter, 1 grams per ml, and 62.43 pounds per cubic feet at, take note, 4 degrees Celsius and 1 atmosphere. It is not 25 degrees Celsius. Be careful to that also, ha? Because science told us that the standard condition of temperature is always from 20 degrees Celsius up to 25 degrees Celsius at room temperature, if specified specifically. Otherwise, not specified, that would mean 25 degrees Celsius at room temperature. Okay? So because some problems don't mention the temperature, it will just say in the problem that at room temperature, the benzene and the acetone will go in the distillation unit. What is the distillate produced? Ganon. Diba? So you should troubleshoot also. It's gonna be like that. Okay? So, going back. So density times the volume. Ato nakita ko ang volume. So, V, kay pareho naman siya, V ra ba ang velocity? Gamayon na to ang V, ha? Okay, to distinguish. Okay, so, density times big V, which is the volume, and then times the small V, ganun siya. So, kung nanata siya volume class, ang mabili niya mo na siya. So, volume, cubic meter. So, ang mabilin, meter per second squared, right? Kaya wala pa man gamit ang second, ano yung higayon na. So, density, so cubic meter, that is the volume. Ang mahabilin, meter over second squared. Then, ang meter length na siya. Okay, guys? So, density, volume, length over, so balik ko na po siya na ito nga, S is the T. Okay? Since meter per second is velocity, so ato na po na siyang i-convert. Mahimo na po na siyang density, volume times, okay, meter per second, velocity, okay, velocity siya, and then mahabilin niya ang second na lang sa ubos. Charot. So, T, capital T. Charot. Okay, this one. So, density, volume times velocity over T. Sir Sotero, where did you get the density? Density is here, kilogram per cubic meter. Volume is here, cubic meter, right? This one. Okay. And then meter is the length. Okay? Like that. And then meter per second. So, napayo sa second habilin. So, T, mo na siya ang T na lang siya. And velocity here, pare sa cubic meter. So, it's gonna be density, capital V, times velocity over T. Okay? Like that. Okay, napamagin siya yung habilin nyo sa ka-S. Get the point? Nadyo siya mabilin ka. Velocity, meter per second naman siya. I-avoid mo na itong acceleration because we're not using acceleration in the momentum transfer. So this is equation 1 from second law of Isaac Newton, the 3 laws of motion. Okay. Now the other one will be now the inertia. So, ganun. Really, okay? So, Reynolds number by definition technically is equal to the inertial force. Inertia, ha? So, itong inertia, the law of inertia, first law of Newton, Isaac Newton. So, inertial force, okay, over inertial force over the viscous force. Viscous force is just viscosity, ha? And inertial force is just shear stress. Okay? Viscosity. Okay. Or viscous force. Mura na siya. Okay? Okay. And sometimes also in examination, it will say like blank is the ratio of a shear stress per unit viscosity. And there's no choices, only fill in the blanks. So your answer will be Reynolds number. Again, blank is the ratio of the shear stress per unit viscosity. So your answer will be Reynolds number. Because ratio is just a division. Okay, that's why per, P-E-R. Okay, per unit. So meaning nagid siya, numerator and the denominator. So may sigutan per unit volume. Okay, just like pressure. Pressure is equals to the applied perpendicular force per unit area or surface area. So that is pressure. Pressure is equals to force over area. Okay, the definition is like that. Perpendicular force applied per unit surface area. Okay, it's gonna be surface area, not the cross-sectional area. You get the point? Okay, duha ra ba ka klase? So, cross-sectional area and surface area. Okay, but when you talk about the pipe, it's gonna be cross-sectional area, the pi r squared, ha? If you talk about the surface area, it's gonna be the the length times width. Okay, if that is a rectangular. But for the square, it will be s squared because the same size, right? But for the sphere, 4 pi r squared. Ganon. So, timanan dito yung mga formula ng mga ito. Itong mga sa geometry. Sa trigonometry. Kaya magamit man ito siya sa fluid flow or sa momentum transfer. Okay? Movement na siya with velocity gradient. Okay? So, Reynolds number is equal to inertial force over the viscosity. What's this one? Viscous force. Charot. Now, makita rin sa ito formula sa viscous force. Ano sa man ito? Charot. Tempasa. Charot. So, okay. Viscosity is equal to tau. Tau din siya. Tau times area. Dili tau nga person. Tau is a Greek symbol. Represents the shear stress. Muna siya. Viscosity is equal to tau over area. Okay. Shear stress is equal to the velocity. Okay. Like this. Times the change in the speed or the dv/dt. Okay, ganun siya. Or dv, shall we say the dv/dl. Okay, the length, not the time. Because kung ano na siya steady state flow. In steady state flow, guys, the time will not matter, ha? Get the point? Mucho din yung subtone. In steady state flow, the time will not matter. It assumed to be constant and negligible somewhere along the points of the medium being considered. For example, if this is your pipeline, the time here will be just constant and equal, so it held to be constant. It will not matter, it will not affect. So that's why we need to say volumetric flow rate at point 1 is equal to volumetric flow rate at point 2. Mass flow rate of point 1 to mass flow rate of point 2. Then apply theory equation. Dayon siya. Itong daghan kasi mga konkuan. Itong mga energy, mga kinetic energy, potential energy, mga ganun chuba-chuchu. Apply ito ni mo siya makakuha di ka mga konkuan. Okay, di ba? So, ganun siya. So, tau is equals to, muna siya ang may tabo, no? Kay tahan. Ganun siya. So, viscosity. So, taon dyan mo. So, mu times dv/dl. Gamay niya siya nga v, ha? Kay, kuan man siya, velocity. Okay, dv/dl ang tau. Okay, muna siya. Tau is equals to, mu times dv/dl. Okay. We don't need to integrate this, and we will have limits because we are not interested for that. So we just go to the algebraic expression, not the integration and differentiation part. Okay? Actually, pag may mga dv/dv ganun, what comes in our mind is we'll be able to apply calculus, right? and take the limits. Okay, but in here, it's not, because we are just deriving the basic linear expression of the Reynolds number. Okay? So it's gonna be like that. So, ayun mo kalibog gusto ng mga DV, ganon. So, we need to focus to the most basic and simplified formula language siya. Okay, now, so mu is equal to dv, guys. Diba velocity siya? Okay, put capital V. Okay. Ang dl, di ba length? Put capital L also. Okay, ganon. Now, this is the tau. Tau pa rin siya ha. Since you say, viscosity is equal to, or viscous force is equal to the tau over the area. Times saan pa rin mo siya area? Okay, it's gonna be viscosity. So, atong i-suwat sa viscosity ka ng V siya, na marag siya tako, para kung hindi ka maglibog. Ganyan ka siya V na gamay, right? Which is the velocity. V nga dako, which is the volume. Yung V na gamay nga naipako, muna itong viscosity. So, English translation. Okay, small letter V with wings. Okay, with wings. Chicken wings. Okay, velocity with wings. That is the viscosity. That small letter V with wings. Okay, small letter V without wings. That is the velocity. Capital V, that is volume. Okay, so that we will never be confused. So we now viscosity or viscous force equals to the small letter V with wings. Okay, like this. With wings. Diba? So this is viscous force or viscosity. It's equals to tau. Mo na itong value sa tau. Mu is equals to VL. Mu is just kuan. Ano siya? Kinematic viscosity also. But this V na ipako, katuli siyang standard na viscosity. Okay, because as I told you earlier, there's a lot of viscosity. It depends on the formula. So in this topic, there's a gray area. So when I was in college, I did not understand very well. My gosh. But what I did, I'll just memorize all the equations and formulas. Something like that in related to momentum transfer. So that wala maka-episode. Okay, so since I am not having the high IQ, I don't have a very high IQ or mental ability in mathematics. So what I did, I memorized a lot, all the formulas and equations, and I just understand. Since I know, I can interpret well because, I have English capability. I love English too much. Okay, so bumabawi ako doon sa interpretation. How I interpret the problem, for me, matters the most. Okay, because di naman siya Tagalog. Okay, di Cebuano, di siya Chinese. The questions are written and emphasized in English. So it's very easy for me to interpret well. Okay? Especially sa mga katong mga and, mga but, mga preposition, because it matters a lot in a sentence when you analyze the problem sa mga conditions. Okay? For example, this one sentence, comma, after that it will stop, meaning this comma is just only referring to this. So your analytical thinking analysis will be only here, and you will cut that there. Something like this you will interpret in that way. Okay, so even though you are not good in mathematics, you're very, you can still understand. Okay, especially if you memorize a lot of formulas and equations. I did not say I memorized everything, I memorized a lot. Okay? You get the point? Kung di ka mag-memorize, mga multi-juga sa chemical engineering. Okay, because there's a lot of equations and formulas. Okay? Na ma-shock lang ka in the examination. Okay, so you're gonna be like that. Okay, so it's gonna be small letter V with wings, the viscosity, right? It's gonna be ganon siya, no? So pi times area na ka. Imo na ito siyang i-multiply diri ari. So imo na siyang i-multiply. So mo na yung metabo mu times VL times area. What is the unit of area? That is meter squared, centimeter squared, or inches squared, whatever. Okay, as long as it's the length raised to the power 2. Okay, so I will put general man, so capital L raised to the power 2. Okay, capital L raised to the power 2. Take a look, class. They're similar with the capital L up and capital L down. We need to cancel that one L here. So what will be left here will be the mu times the velocity times the length. Okay, it's gonna be like this. This is equation number 2. So ganun siya. Equation number 1 and equation number 2, divide this 2 and you have the Reynolds number. Okay, let's try. Okay, so i-memorize na lang kayo para kita mag-derive. Okay, kapoy po ba yan? Diba? Pero, the sad fact really, because if you are, if you're really an engineer, you know how to derive. So that's really the fact. Because if you don't know how to derive, you're not an engineer. Okay? So that's the reality. Okay? All engineers can derive. Okay? So it's gonna be like this. So Reynolds number is equal to inertial force mo na ni siya, equation 1 kani siya, density V, ganon. Okay, copy that here. In a way, if it commits error, we'll go back only. Okay, we will review. That's the normal process. Just like in journalism, you have to review and proofread your articles and columns when you write an editorial article, an easy writing article, for example. So you have to review, you have to eliminate the redundancies, the jargon, the duplication of thoughts so that you will summarize that one to have a standard brevity. You know brevity? B-R-E-V-I-T. Brevity is the maximum number of words allowed in writing that particular, for example, feature editor, feature article, editorial article, essay article, poem, poetry, short story. Short story is different also from poetry because poetry is just a little bit longer compared to short story. Okay, poem can also long, can also be shortened, but short story from the word itself is short only. Okay, and then we have also, you can write also the novel, Nobel, N-O-B-E-L. Diba? Nobel Prize Award. So it's gonna be like that, Nobel, N-O-B-E-L. So that's also part of journalism. Okay? Something like that. So you should be take extra careful, something like that. Okay, so there's a limit for that. I forgot. Really, what I remember only that the maximum number of maximum words for the title is 8 words. Okay, for a good title in your column or articles. For example, me, if I am a reporter, a broadcast journalist, I am a columnist, I will write an article about, for example, pandemic, ganon. Pandemic crisis, ganon. So I will write that 8 maximum words lang siya. Because if you more than 8 hours, it will not qualify as your title, so as your heading. So it will be short only, as much as you could. Very easy to read and very quick. Okay, so you should not have a very long title, something like that. So it's just the same here also when you write a formula. It should be simplified. Okay, simplified and easy to understand, easy to comprehend. Okay, like that. Sakto ba? Comprehend. Oh, sakto siya. Okay, so Reynolds number is equals to the density volume times the small letter v without the wings over T. Ganon. Okay? And then, the viscous force mo na siya, no? So, mu is equals to VL. Kakaloka. Then, take note guys, musama po dyan ang T. What can I do about this? Okay, this, it looks like the T will intrude. Wow, intrude meaning will disturb. Another term for disturb, intrude, like interrupt, disrupt. Those are synonyms in English. The same meaning. Okay, disrupt, interfere, intrude, I-N-T-R-U-D-E. Okay, So something like will intrude in this numerator. So what can I do for this t? I have to abandon this letter t. Abandon meaning to reject, to eliminate, to phase out. Okay? You get the point? I have to eliminate this one t. I have to reject and eradicate. Okay? So I have to eradicate the capital T in the numerator. Okay? So what I'm gonna do is I'll be able to simplify the specific unit of the capital T. So that is second raised to the power 2. Okay. So density capital V times small letter v. Okay? Over second. Okay? Like this. They're not second because there's letter D at the end of the word. Second. Oh my gosh. Parang nangangaral ng pronunciation and diction. Okay? So over viscosity times the volume times the length. Chart. TH sound. Length. Charot. Okay? Okay, like that. So I learned this sounds sa English. Okay, English when you study, right? And because I joined also speech contest before when I was in high school and speech choir. Okay, and then oratorical contest I also joined. Okay, but I never joined declamation contest, Okay, that's oratorical contest, extemporaneous speaking, something like that. Okay, I joined for that contest. Okay, so going back to this formula, Reynolds number is equal to density and volume times the velocity over the time second over the denominator viscosity times the capital V times the length. So, what do you notice for this? S is already the denominator of the velocity. Okay, so we need to substitute that V. So, meter per second. You got the point? Ganon. So, density, capital V, then meter per second. Okay, meter per second over second. Diba? Diba, guys? Velocity over second. So, it's gonna be meters per second, which is the velocity or the speed over second. That's right here. So, meter per second over second. So, what do you notice here? What do you notice here? Okay, so viscosity times the volume times the letter. Okay, ganun siya. So, ang mahirap sa metabon, mag-cancel-cancel na kawat is na common. Okay? Kani siya nga higayuna. Okay, unsa may common sa the numerator and the denominator? So of course, the capital V volume will be cancels out because it is from numerator and the denominator. Okay, you will cancel that one. Okay, so V is equal to, ganun, ang habilin mo na lang ni siya. Oh my gosh, how can I do this? Okay, so this one is the meter. Okay, meter per second. So balihonan na mo siya. It's gonna be like this. Papel please. Papel please. Okay? Ganon siya. Ganon siya, guys. Okay. So it's gonna be like this. So density over meter per second over second. Okay? Over mu and L. Okay, guys? This one. You get the point? Muna siya netabo. Okay. Now, meter per second is the velocity. Mag-divide that M over S to S sa may metabo. What you will do for that, the rule in algebra. So, understood ko na siya nga S over 1, right? So, it's gonna be 1 over S. So, meter per second times 1 over S. Diba kanya siya? Muna siya matabo. So, meter second. So, that's gonna be length. Okay, length over the T. Okay, ganun siya. So, that is density, velocity. Okay, and then over the T, over the mu, over the L. Okay, L. Now, the L will cancel because of the meter per second. The numerator is ml, may gapon na siya. So density is equals to meter per T over T mu L, cancel L, ganun siya. So it's gonna be density, okay, T times 1 over T. So makancel siya. It's gonna be density over mu ang habilin. Density over mu. Is this the formula of Reynolds number? The question is this the formula of Reynolds number? The mu over the viscosity? Do you, anybody? So this is gonna be our option 1. Density over mu is equal to the Reynolds number. Okay? So this is option 1. And now we go to the option 2. Okay? Okay? May option si June because I did not script this out. This is not scripted. Okay? So mag-option June ko. Hindi na pag-yuta to edit so ano? Nakabantay mo, mag-vlog ganun ko na yung mga option 1, option 2, option 3. Hindi din ko makakuha sa diretsyo, right? You get the point? Because, you know, I am not having a very high mathematical ability. Okay? So, average. Okay? Because if I have a very high mathematical ability, I can really obtain directly sa option 1 pa lang, correct na akong derivation. Okay? Di ba? So, let's admit weakness and flaw. Okay? So, okay. But ibig sabihin ng self-praising. Okay? That you know all. Okay? Know it all attitude is very bad. You should accept your flaw. Okay. F-L-E-W. Flaw, meaning your weakness. Okay? So, let's have option 2. Okay? So, mugyo na akong pirigin akong sa akong vlog ha. So, di ko makakuha na yun. So, nasa time, but more jud siya nga mag-option jud ko. Because the main reason for this, guys, is I don't script. I don't have a scripted vlog. Okay? I did not prepare. Okay, what to do, step 1, step 2, step 3, step 4. That's why it will take longer time, right? So, it's gonna be my weakness. Okay? And what comes on my brain cells, I will try to talk with you directly. Okay? Like that. So, it's gonna be maraming side talks. Okay? So, let's go to the option 2. So, our option 2 is gonna be like this. Okay. Reynolds number is equals to inertial force, okay, over viscosity. Or viscous force. Okay, guys? Muna siya ha! At yun yung kalimti. Mugin siya, really. Okay? So, the Newton's law of viscosity is very, very important in the momentum transport phenomena. Newtonian fluid, non-Newtonian fluid, very important, guys. Using the Bernoulli theorem equation. Okay? So, you have to remember this one, ha? Okay. Inertial force. Ganon. So, force is equals to mass times acceleration. Okay? Mass times acceleration, so meaning to say density times the volume. Okay? Times letter over t raised to the power 2. Okay? Letter over t raised to the power 2. Okay, ganon. So, option 2. We don't need to break up yet. Let's see. Okay? And then this general. And then also the value of viscosity, we don't need also to break up. Let's see if their units will be cancelled also. Try until you die. Something, no. Okay, so we have viscosity. So viscosity or viscous force is equals to tau, which is equals to the mu times the velocity over the length. Okay, ganun siya. Area, which is L squared. right? And it's gonna be cancel, and mu VL. Okay. I-substitute diretso without simplifying first. And dito na kamo simplify if na siya sa formula. Because what we did before, we do it individually before plugging that in the formula. But in here, we don't break that units one by one, but we need to put that in the formula, and then it's in there that we will simplify pa. Okay? Because there's two types of techniques, right? You have to break it out first and then substitute to the formula, or later na siya, ipasok mo na nimo siya sa formula. So it depends on the situation, okay? What is your convenient and comfort? Okay? Like that. Because we don't have the same comfort and convenience. Okay? So different students have different convenience how to do it. Okay? This is only an idea. Okay? That this is gonna be like, we can derive this Reynolds number. Because most of the time we will memorize. Okay? And we don't know where does it came from. Get the point? Just like the ideal gas law. Where did the ideal gas law came from? Okay, it came from the thermodynamics, second law of thermodynamics. It's in there. Because you can derive the pressure, volume, okay, the thermodynamic properties. So it's in there. Dapat kamao ka ba diin gikan. Okay, so that kung makalimot ka, you can just derive. Okay? Get the point? No na siya natabo. Okay, so inertial force equals to density, volume, length over t squared over mu v L. Ganun. Now, it's in their class that we need to break it up na siya. Okay? Kasi break it up. Uy, ato siya i-break. Okay, pasok naman nato. So, density is equal to matter, okay, velocity, density, velocity, gano'n, okay, t squared over mu VL. So, dito na lang ito cancel ang V, ha? Okay, huwag mo dyan na siya ilabot ang V, kaya makancel magida yung good. Okay. Now, LT squared. So, kani siya, guys, tanawa na gud na ninyo. Diba, ang L nasa ubos. So, it's gonna be like, inikakuan mo niya, mahimo na siya L squared. Di siya makancel. Okay, kaya anak mo na siya L over T2. O, L over T2 times, supposedly, L. Diba mo na siya sa L. Mahimo mo na siyang 1 over L. Okay? So, muna siya matabo. Hindi mo siya makancel. Okay, it's gonna be matter second squared, okay, and then times the matter pa siya. Okay, ganon. Kani siya, guys. Okay? Dito point. Okay, now, kung mo na siya yung metabo, ang habilin mo na lang siya. I want to translate in English. Okay. Sorry. Nagbisaya na si Jule. English interpretation. Wow. Okay, guys. Ito na mga scratch paper. Okay. So, cancel siya. It's gonna be, so matter. Asa naman to siya? So, matter second squared times matter. Diba, guys? Okay, so this is gonna be matter squared S squared. Okay? Now, since we have matter per second is the velocity already, okay, so what will be left is the matter second. Okay? You got the point? So, matter second. So, that is velocity. Okay? So, density times velocity. Okay, so density times velocity. Okay? And then, kinapaman siya ang mabili niya meter na lang, di ba? So that is length. Okay? Tanawa good. Meter squared ba ya siya? Over S squared. So, kung paano mo sa meter, ang mabili na niya, kaya kuha na lang siya. Meter per second. Ang usa ka, velocity yung usa kay meter per second, mabili, meter na lang siya, length. So, density times velocity times length. Okay? Ganon. Over mu. Okay, ganon siya. You get the point? So the formula of Reynolds number, this is option 2. Density times velocity times the length over the mu. Right? Tama ba siya? This one. Tama ba siya? Take note. Tama ba siya, guys? Dili. Density, velocity, times length, and Newton. Awan na yung mga libro. Mao ba na siya ang formula sa Reynolds number? Density times the velocity times length and the mu. Or kari ba siya kung sa option 1? Asa ito option 1? Okay? Kuan. Density over mu. Asa may saktuan niya? Google. Asa mo go? Mag-google ka asa saktuan niya. Charot. So, ay ato na lang i-breakdown ang units sa kuan sa Reynolds number. Tingnan na to mga basindig unitless ang Reynolds number. We don't know, right? It's gonna be okay. Hinumduman ninyo ang Reynolds number na if 2,100 below, that's gonna be laminar. What ba ni specified unit dito? Okay? So, di ba? Bisan sa kung hinumduman na. And then if more than 2,100, it's turbulent flow. Right? So that is more than 2,100. So it's gonna be, wala units ang Reynolds number. So makancel siguro mga units ani. Kung iyo mo siyang tagsa-tagsaon o butang mga units. Okay, sige. Ato ko nung tagsa-tagsaon. Okay. Tagsa-tagsaon yun. Okay. So, mo ni siya natabo. Kani siya nga formula or kanino sa. Ato na lang ni Google para madali. Okay. Google! Because I have derived already. Okay. Pila may answer niya, guys. Reynolds number, no? Tempera, let me Google first if this is the correct formula. Reynolds number formula. Reynolds number. Okay, formula. It's here, asa naman yun? Reynolds number. Ganon. Because I have only 2 cell phone. How can I do this? I cannot Google. I cannot use the laptop also. Reynolds number. Guys, no internet. Charot! No data. Basta, naraning duha, pero I'm pretty sure mo ni siya. Kaya what I remember, daghan mo to siya quantities ng Reynolds number. It's gonna be this one, not this one. Because I don't remember also this one in my entire chemical engineering life. This kind of formula. Density over mu. It looks like, strange or unfamiliar or unusual. Okay? But here, it looks like familiar and common. Density times velocity times length times mu. So, this is gonna be like the formula of Reynolds number. Okay? Kaya naman siya viscosity, yun nasa siya inertial force. Ang inertial force, bubatter diyan sa velocity. Okay? Yun din nawa ang velocity. Sige, hindi na siya inertial force. Density na lang siya. Charot! Di ba? It doesn't make sense. Wala siya velocity. Velocity ba is the gradient ba sa momentum transfer. Sometimes also theory will do, Okay? The theory and the concepts will do. Okay? To analyze things. Okay? Like that. So, if that is the case, we defeat our purpose. There's no velocity gradient. And since momentum transfer is The driving force is the velocity. How come there's no velocity in the equation? Okay? You get the point? So this is gonna be technically correct. Okay? Density is equal to the velocity times the length over the mu. Ganun. Thank you so much guys for watching this live streaming. I hope you like this. Okay, and then you can comment down below the comment section, and then you can subscribe my YT channel if you like, and you can click also the notification bell for some news updates of I am a singer. Eternal. Bye-bye na. Kapoy na kundila nasapin. Thank you so much. God bless everybody. Okay? Nasapin akong dila.